I'm sorry.
I brought it up so I wouldn't forget. Okay, 3-4 linear programming today. You got lots of vocab. These are those nasty problems. You'll see at the very end, we do this one problem that'll take like 20 minutes for us to do. Shape equations, graphing, all that fun stuff. So this is leading into that big, nasty problem. If you were in person and I didn't have my fancy little smartboard, that single problem would take like 3 full whiteboards to do. That's how big it is. Just so you get setting the stage, so to speak, today. So 3-4 linear programming. I love these mathy sort of definitions. This is an impressive one for linear programming. It's a method for finding a minimum or maximum value of some quantity given a set of constraints. It's 100% true, that definition, but it really doesn't tell you a hell of a lot until you know what the linear programming process is. So it talks about constraints, right? So if we're thinking about a simple kind of problem like we're planning, we're a farmer, right? We've got a field. We want to know what we should plant in the field, a mixture of things, so that we can maximize our yield, which in turn maximizes our profit. So if we're planting like corn and soybeans, how much corn versus how much soybeans should we plant? You would do a linear programming kind of problem to figure that out, so you can maximize your profit, right? That's what we all want to do. So those constraints will get us towards this feasible region here, right? So we don't know exactly, well, that's a weird feasible region they drew there too. It'll hardly ever look like that. Normally it's kind of down here in the corner of a graph, but not always. So we're going to get the constraints of the feasible region and plug them into a profit kind of equation, right? So we're going to get the ordered pairs from the corners and plug it in to see which one gives us the biggest number at the end. That's kind of the whole purpose of this thing. So when we do the big problem, we're going to read this big fat story problem. We're going to come up with 5 to 6 equations. We're going to solve those equations, get them into slope-intercept form so we can graph them. Then once we graph them, we'll get the corners like I indicated on the graph, plug them into a profit equation to see which one maximizes the profit. You could also have equations where you're trying to minimize things, okay? So let's say we want to drop 10 pounds, and we want to minimize like fat intake or sugar intake, whatever the case may be. A lot of times our weight gain is around sugar. More so than fat, so you can limit your sugar. But that could be another kind of problem where you would do this whole linear programming process to try to figure out how you can limit your sugar and then in turn lose some LBs. Okay, the feasible region is the shaded part, right? It's determined by your constraint equations, and every little dot within the feasible region is a potential answer. Okay, the dots along the line can be potential answers as well. But what we'll really do is just plug in these corners. So if we're trying to maximize, let me erase this. It's starting to look like it's got measles or something. When we're trying to maximize, if I'm trying to decide between these 2 points, it's probably not going to be that point, right? Because this x value is bigger, even though the y value is the same, the x value is bigger, right? So you don't always have to plug into every single point we're going to talk about. It just kind of depends on the situation and the problem. So do the little virtual hand raise thing once you're done writing up these definition pieces down, just so I know. And I'm just waiting for a couple people to finish writing in person, and then we'll move on here. There's only 6 slides, but we will add a couple just because we got to add slides to graph stuff. like we're almost done. So remember, you guys, when you're graphing, x equals is going to be a vertical line, y equals is going to be horizontal. When it says x equals, it crosses the x-axis. That's what makes it vertical. When it says y equals, it's got to cross the y-axis. That's what makes it horizontal. It's one of the most overthought sort of things when graphing, which should be totally easy. Okay, so if you got your hand raised thing, take it down, please. And we're going to move on. We good? Okay, so write those constraint equations down in the top right and the profit equation in the blue box. And then the two equations we're going to solve and put into slope-intercept form. Don't forget, you guys, when you divide that second equation, we're going to have to divide by negative. When you divide by negative, you got to flip the inequality. So just remember that. We'll give you a sec to write these down. So the first two problems we're going to do here are basically like the nuts and bolts of the linear programming without the story problem portion of the program. So we're just going to be writing these equations and graphing them and then plugging them into the profit. We'll say this is a profit. We're trying to maximize. So pay attention, because you have one problem in your homework where you're going to minimize, so you're looking for the smallest value. Okay, if I quiz you on this, I told you I might give you a quiz this week, but when I said that, I didn't realize we didn't have school on Friday. So you won't have a quiz until next week. We'll figure it out. I'll probably do 3-4 and 3-5 quiz then, because I don't want to give you a quiz right when you come back from a 4-day weekend. Generally not a good recipe for success. So we'll do 3-5 when we get back. And then have a review day and a quiz, 3-4, 3-5. So definitely pay attention when it says maximize or minimize, because that's obviously important. First equation on the left here, we're going to subtract x from both sides. And we're going to do the same thing on the equation on the right. On the left, we're left with 2y less than or equal to negative x plus 5. On the left equation, we're left with negative y less than or equal to negative x plus 2. The equation on the left, I got to divide by 2, all three parts. On the right, I have to divide out my negative 1. So on the left here, we end up with y is less than or equal to negative 1/2 x, plus, I'm not going to leave it as 5/2, simply because it's a pain in the ass to graph. I'm just going to make that 2.5. Okay, second equation here, we're going to get y. We've got to flip that inequality. Don't forget to flip. So we're going to get y is greater than or equal to, I'm just going to put the 1/1x, right, so I have a slope to count out. You don't need to do that. Don't do that. It's fine. Then we're going to take these two equations and graph them on the next page. Remember, the easiest equations to forget are these two equations. We don't tell you you need those two equations except for the fact that I'm telling you you need them right now. Like when you see a problem, they don't tell you you have to have x and y are greater than or equal to 0. Remember, this single problem you're going to be quizzed on is going to be worth 12 points. If you forget that x and y is greater than or equal to 0, you would lose 1 point. Okay? So don't forget that. It's so easy to forget it and lose that point. It'll just make you mad. So this means we're going to force this whole thing into quadrant 1. Okay? X and y are greater than or equal to 0. No negatives allowed. So I'm only going to show quadrant 1 when I graph. And we're going to start up. We'll do the top one in purple. Like, organized use of color could not be more important on these kinds of problems. It's just that you'll get super confused if you don't stay organized. So we're going to start at 2.5 from there. We're going to go down 1, rate 2. And I'm going to go until I'm below the x-axis. Draw my graph. So again, I like to think along the way as I do these problems. Sophie, questions?
Why are you forcing it into quadrant 1 again? That confused me.
They just told me to right here.
Ow.
That's why. But many times in these problems, I mean, it's always still a valid question, right? Well, like the one we do later in class, we're talking about like t-shirts and sweatshirts. And we can't have negative t-shirts or sweatshirts, which is why we'll force it into quadrant 1. For this one, they just tell you. So we're going to start at -2 on the next one. And we're going to go up 1, right 1. I like to go until I meet the other line, because sometimes that's an order pair that I need. And then I'm damn sure that I get the correct order pair. So these two right here force me into quadrant 1. So I'm basically done with those. I don't have to think about them anymore. But I'm less than purple and greater than blue. So less than purple, greater than blue means that I'm going to be in this little wedge in the corner, kind of. Less than purple, greater than blue. So above blue and below purple. Now, we need to write our profit equation, which was 2x plus y. So when I get that profit equation, I'm going to think about the order pairs that I have. So the corners of the shaded part, this order pair right here is 0, 2.5. Where the two lines cross, the blue and the purple line cross, that is 3, 1. And then I've got this order pair right here, which is 2, 0. So if I'm trying to maximize, and I'm choosing in between 3, 1 and 2, 0, I know 3, 1 is going to give me a bigger number, so I'm just going to cross out 2, 0. Okay, so I don't need to plug that one into my profit equation, my objective function. We're using those interchangeably. Profit equation is an objective function. Think about it intelligently so you can do less work. So we're just going to plug these in now. So I'm going to plug in 0, 2.5. So 2 times 0 plus 2.5 equals 2.5. Then I'm going to plug in 3, 1. So P equals 2 times 3. So I already know that one's going to be bigger. Plus 1. 2 times 3 is 6. Plus 1 is 7. And if I plugged in 0, 2.5, I would just end up with 2.5 again. So again, think intelligently before you plug these things in so you can save yourself some work. I knew, because I've done these a bunch, that this one wasn't going to work before I plugged it in. But I just wanted to show you, like sometimes you got to plug in more than one of them. Sometimes you'll end up plugging in 3 of them because they'll all be kind of close. But this one is the one that maximizes your profit. Okay?
You do the bottom one sometimes, like why do you do it?
Well, the bottom one sometimes, because 2 times 2 is 4, and I just knew that 3 is bigger than 2, so that's why I didn't do it. Because if I'm plugging in right here, that 3 is going to give me 6 already, and I was already done at 4 here. So you can always plug them all in if you're paranoid about it, right, just to double check and be sure. But let's just show that real quick, just so you can, sometimes it's good to get the visual. So 2, 0, plug it in, so P equals 2 times 2 plus 0, which would equal 4. So just plugging them all in, and then you can see better, like, so you got to think about, sometimes the numbers in front of the X or Y will influence which of the points you pick, so you're kind of thinking at that level along the way. Sophie?
How do you figure out which points to use? What points to use?
So I'm just looking from, this is a totally good question, right, the corners of the shaded part.
Oh.
Right? So I'm not going to pick 0, 0, because clearly that won't give me the max, but it would give me a min. But we're trying to maximize here. So just the corners of the shaded part are the ones that we plug in here, here, and here. Okay? So that was like the key question for you to ask right there, right? You're like, what the hell is going on? Okay, so the rest of you guys ask those key questions when you're combustible. Nice Argyle on Malfoy today. Like it? Very good. Okay, so write these down. We're going to practice one more kind of nuts and bolts with the linear programming, and then we'll move on to do the nasty little story problem. It's going to be joyous. You will love it. So again, this one's forcing us into quadrant 1 with the x and y are greater than or equal to 0. So when you think about graphing, just think about that. So we got to solve these equations for y so we can graph them. First equation on the left, we're going to divide by 3. Second equation, we're just going to subtract that 2x over. So the one on the right, we get y is less than or equal to negative 2x plus 8. And then on the left, we get y is less than or equal to negative 1/3 x plus 3. The story problem we do has 6 equations, because that's fun. It'll meet your expectations as far as fun goes. Good times. You know it. Yeah, I know. Building anticipation. They teach you this in teacher school. Okay, so I'm still waiting for a couple people to finish writing.
Is this the freshman year you told me I will cry now for 2? Is this one?
This is one of them. One of those moments, yeah. Just wait till we get the story problem and you see the entirety of the story problem. You're just like, what the?
I'm already stressed out about it.
Just know that you can do it and you will do it. You are an intelligent young woman. You will do it. I have faith in you.
So I'm not saying I'm not do it. I'm just saying that I
You're stressed out about it. Yeah.
You said our quiz on this is going to be next week?
Yeah, it's got to be next week because you guys got Friday off.
Oh, thank God.
So it'll be, I mean, the one problem on this quiz will probably take you about 20 minutes. We'll do one like this. That'll probably take you 10 minutes to do this problem, 20 minutes for the big problem, and then I'm probably going to throw in a 3-5 question for good measure. So it'll be a juicy little quiz at the end, towards the end of next week.
Me and Amanda are gonna cry next week.
3-5 is 3 variables, solving systems of equations with 3 variables. So it's just,
Amanda and I have a chemistry test, quiz, and 2 labs next week.
oh God, bless you, America. Yeah, that's rough.
And that's why I didn't take chemistry.
Smart woman.
I decided I would flip up the pain.
That's good. Remember that in college too.
Oh, I will.
You get some semesters in college where you just
Well,
get
I
totally
actually
abused.
forgot to sign up for chemistry.
Now we know the real reason.
Yeah, and I was very glad when they were like, oh yeah, you don't have to take chemistry.
Oh, you're
You
fine.
can take next year. I was like,
So don't forget about that profit equation, right? So we're in quadrant 1 on this thing, so no biggie. This will feel a lot better just doing this one as compared to the last. At least that's my hope.
Mr. Evans,
Yes, sir.
on the first equation, you cut off the -1 there.
Just the tiniest little bit in the 3.
Yeah.
Does that make it that inside, Trevor?
Yeah.
There you go, it's all better. He's smiling at home, so. Okay, we're going to do, hold the phone. We'll do that one in blue, this one in purple. So the organized use of color, especially when you do the big fat story problem, you're going to want 3 different colors because we've got 3 primary equations we're going to graph on the thing. So it'll just help you keep everything straight. So I know I've freaked you out by talking about these problems for so long. You're all going to be fine. You're going to do it. I will teach you until you do. Okay, so we're starting with the blue equation. We're starting at +3. From there, we're going to go down 1, right 3. And I'm going to count all the way until we get to the x-axis. Because sometimes you need those order pairs. And if you know for sure what that order pair is, it's just less stressful.
Right?
Down 1, right 3. Because we go down is a negative direction and to the right is a positive. So when it's a negative slope, you have to go 1 positive, 1 negative direction. So we went down 1, that's a negative, right 3 is a positive. Next one we're going to do is the purple. We're going to start up 8. And then we're going to count down 2, right 1. Good to get those places where the equations meet. And graph that one. They all go super well until it goes wrong, and then when it goes wrong, like the ability to recover and figure out what you did wrong is the challenge to these problems. Like the process is fine as long as you don't screw it up.
I'm going to bring my makeup bag the day of the test.
Yeah, you can reapply.
The more you talk, the more stressful.
I know. Maggie's just like, it's getting a fever pitch.
Unless you do one little
Unless you
it all goes haywire.
Right? You forget this negative right here, you're completely, yeah. Okay, so we're less than blue, less than both here, is that right? Less than both, yes.
Yeah.
So less than both, which means we're going to be in the corner. So we're trying to maximize, right? So when I pick, you're just getting the corners of the shaded part. So I'm going to use these 3 red dots to plug into my objective function. The first one on the left here, that is 0, 3. Next one in the middle, 3, 2, good job. And then the one down here is 4, comma, 0. So if I look at my objective function here, right, p equals 4x plus y, I'm not going to plug in disordered pair. Right, because if I plug that in, I only get 3. So clearly that's not going to be the one that maximizes. Again, if you don't realize that, you can plug them all in. It's fine, and just see which one gets you the biggest number. Again, I like to take the shortcuts when I can. So I'm going to plug in the 3, 2 first. So I get p equals 4 times 3 plus 2, which equals 14. Then I'm going to plug in 4, 0. So p equals 4 times 4 plus 0, which equals 16. So the 4, 0 is the point that gives you the maximum amount. Good job. I saw a little smile. It's funny because you can only see the smile in the eyes now, you know, so it gives you a whole different perspective. Like once we're all not wearing masks again, it's going to be weird to be able to see like the whole face.
I've like bumped into people like on accident and I've been like, oh sorry, and I've like smiled at them and they just look at me like I'm nuts.
Yeah. Well, I just ran into a freshman I taught last semester and like I recognized him, but not a chance on the name. It was so bad. Okay. So that's the nuts and bolts of this process, okay? So get the equations into slope-intercept form, graph them, shade it, take the corners, plug it into your objective function, see which one gives you the biggest or the smallest, depending what it asks for. One of your homework questions does do min, okay, so just pay attention. Yes?
This doesn't seem that bad.
Just wait. Yeah.
For like the highlighted part on like the graph,
Yes.
like how do you figure out that that's the feasible region?
Feasible region. Because they're both less than, right? So I want to be below the blue line down here and below the purple line.
Oh! I got it.
We got another. That was a big aha moment. I love those. That's good. Okay? So take a deep breath. Here it comes. Story, problem, fun. Read the entire thing. You're not going to, I can't make it bigger, sorry. You can pull it up on your computer if you want. I can read it to you, or you could just come move up here real quick and write some stuff down. But I'll write it all down anyway, so don't worry about it.
Actually, I'm getting another sheet of paper.
Okay.
Every time I get a
So just wait. Just to choose how many t-shirts versus sweatshirts you're going to produce to maximize your profit. We'll go through 3 pages on the smartboard here to get there. Okay, so we got t-shirts and sweatshirts. I will always identify your X and Y because, oh my God, if you get the X and Y wrong, you want to talk about problems, you just have no idea the problems you get into. So I will identify them for you just so we're all on the same page. So we're going to do X is t-shirts, Y is sweatshirts. Okay, and I'm just going to read this thing. You are screen printing t-shirts and sweatshirts to sell at the Polk County Blues Festival and are working with the following constraints. So when it says working with the following constraints, we are going to use these 3 little bullet points there. We're going to make one equation per bullet point. Okay? So the first bullet point says you have at most 20 hours to make t-shirts. Second one says you want to spend no more than $600 on supplies. Third one says you want to have at least 50 items to sell. Okay. So on the t-shirt, they have these little tags. The first one says one color t-shirt takes 10 minutes to make. Supplies cost $4, profit is $6. The sweatshirts, they takes 30 minutes to make. Supplies cost $20, profit is $20. So there's the whole thing. They're so happy. Yeah?
Okay, this is nothing to do with the problem, but screen printing of one t-shirt does not take 10 minutes.
How long does it take?
Like 5 minutes.
Well, that's good, so it's faster.
Probably takes around.
Hey, they try to have realistic things.
I'm just saying, I spent the last week screen printing.
Oh, you did? Oh,
It did
God.
not take that long.
Okay, easiest equation I think to write is a profit equation because it literally says the word profit and we're trying to maximize profit. So right here, profit $6 and profit $20. So 6 for t-shirts, remember t-shirts is X. So all you have to write is P equals 6X plus 20Y. So after we graph and shade, that's the equation we're going to plug those corners of the feasible region into. So then I'm just, yeah. Oh, how much have you spent on a sweatshirt? Like you could spend, I don't know, like 200, no problem, right? Depends how cool it is. Okay, so the minutes equation, it takes 10 minutes to make a t-shirt, 30 minutes to make a sweatshirt. So 10x plus 30y. Then it says we have 20 hours. So they're mixing minutes and hours. Not okay. Because we're talking minutes with the 10x plus 30y. So 60 times 20 is 1200. You have at most, so it's got to be less than or equal to 1200. So I got the 1200 by doing 60 times 20. Okay, so the number of t-shirts, they say, do you want to have at least 50 items? So that's the easy equation to write. At least means greater than or equal to 50. So you can understand how not knowing what at least means will really screw you up here, right? At least means greater than or equal to, because if you thought it was less than, then you're shading on the wrong side of that line and your entire problem is jacked. So just be careful. At least means greater than or equal to. Then we have 600 to spend on supplies. Supplies for a t-shirt are $4, so 4x. Supplies for the sweatshirt are $20, so 20y. We only have 600 to spend, so it's got to be less than or equal to 600. So I forgot two equations on purpose. Which two equations did I forget? Yeah, so just don't forget to write those. I gotta see them, you guys, otherwise you lose that 1 out of 12 points. That's like 8% on that single problem if you forget x and y are greater than or equal to 0. You will. I got faith. Okay, so now we're going to solve all these for y. Okay, so new page here, 10x plus 30y less than or equal to 1200. So there's the first one I'm going to solve. Then we're going to do x plus y is greater than or equal to 50. And then last, we're going to do 4x plus 20y less than or equal to 600. So this was the number, so minutes number cost. Yeah, that's my little sausage fingers not cooperating. So staying organized with these problems will help you keep your sanity, because it's easy to get discouraged and freak out with these problems. That is a big assumption. Okay, so we get 30y less than or equal to negative 10x plus 1200. We get y is greater than or equal to negative x plus 50. 20y less than or equal to negative 4x plus 600. So some of you guys will like to just solve one problem at a time, not do one step at a time. I don't care, that's fine. So I'm done with the middle problem. This one I got to divide by 30, all three parts. Right, this first problem, I could have just whacked off a 0 on the end of each one right at the beginning here. Right, that's a legal math move. It just make your number smaller. You can do that if you want to. I didn't, but it doesn't matter. So y is less than or equal to negative 1/3 x. Right, I'm basically dividing by 10 as well as 3 here. 1200 divided by 30 is 40. So we're good with that equation. I'm going to write the second equation below here because I'm going to have to copy it anyways. And then on the last equation, I just divide by 20. And we get y is less than or equal to negative 1/5 x plus 30. I'm just rewriting that equation right here. I'm just going to copy it to a new page, so that's why. Yeah. Not trying to confuse you, I swear. We're going to go by 5s on the scale, that is true. We're getting there. I'd say we're like 60% of the way through the problem, maybe? So, right, page 1, good times. Page 2, full laugh. Page 3, you're having fun. Oops, that's not what I meant to do. I'm also going to write x is greater than or equal to 0 and y is greater than or equal to 0, because I know 10% of you are still going to forget that. Don't be that person. Yep. Because we're producing these t-shirts and sweatshirts, so we don't want to lose money, right? So we're maximizing. So it was 6x plus 20y. For the profit equation, which I'm just going to double check. Yes, 6x plus 20y. Okay, now we're ready to graph. Yay! So again, quadrant 1. We'll do the top equation, purple, middle equation, blue. Bottom equation, yes, we're going by 5.
Oh, okay.
Well, I always show 10s, but it's technically 5s. If the x is going to go out to like 100 and change, I think 110 is the point we need. So 110, 0. That would be 22, depending how you're counting.
Wait, I can't do that. Wait, what are they?
10, 20, 30, 40, 50.
Oh.
I just have to write going down because otherwise it gets too mushed up.
Oh, wait, so how many
Yeah.
things do I need on?
You only need up to 50 on the y.
What if we're going by 5?
So you need 10 spaces.
Okay.
Yeah, 10 spaces up to there, and 22 spaces to get to 110. If you're skipping one and going like I'm doing it. I'll wait till you get your scale figured out. You guys, if you're ready to graph, go ahead and start graphing them. I know, right?
I got 2 for graphing.
Oh, I got
You good? You want, I got another color if you want to borrow another
I
color.
got exactly enough brown on the bottom. Wait, how is this gonna be accurate if we're going up by 5 and you're going like down 1/3?
You'll see,
I
have
don't
faith.
know. That's funny.
Amanda's doubting now. You have faith, young lady. We're gonna get you there.
Right now, that's what I'm
She's looking at me like, this is not gonna work out, Evan. Yes, it is.
really
That's it. Okay, let's start graphing this piece. So purple one, we're starting at 40. We're going to go down 1, right 3.
Isn't that technically going down 5?
I'm going down 5 and right 15, which reduces to 1/3. So that's why keeping the scale is super important, because then I can just count squares, because then I don't have to work my tiny little brain too hard. That's the beginning of a bad joke, if there ever was one. I think it went out to 120.
I don't have enough room to go all the way down.
That's okay. You will on the quiz, because I gave you the graph on the quiz, and I make sure it's big enough. Okay, there's the old purple. Going on to blue, so we're starting at positive 50, down 1, right 1. Again, just go all the way till the x-axis. It just makes your life easier. I'll be a pain in the ass kid that won't do it, but, you know, don't be like it. Green, we started at 30, down 1, right 5. This one we're not going to be able to get all the way to the x-axis, that's fine.
You're going over 5, down 1.
Correct. I love how you get stressed out with graphing too. There's a lot of stuff going on in this problem. You have to rewrite to freak out a little bit. Good times.
You're all doing great.
Yeah.
The graphs.
Makes my head hurt.
I know, just remember how easy it was like 2 weeks ago when you're like, oh my god, this is so easy, I feel so good.
No, just 2 weeks ago was that graphic calculator stuff.
Oh, that's true, maybe 3 weeks ago. Be better.
Yeah, 3 weeks ago, that was one.
Okay, so now we got to think about where we're graphing. So the two lessons are purple and green. So lesson purple and green, right? I could be here in this area, or I could be in this area, but it's greater than blue, which means here is my feasible region. That unusually shaped area right there.
These are going to be some fun numbers.
Good times. Okay, so I'm going to get the corners. I'll do the corners in red like I have been. So we've got those 4 places that we can plug in. So we don't want to pick the dots kind of in the middle like this. We only want to pick the corners, okay?
I don't have enough time to do that whole stuff.
Just write it, that's fine. The iPad failed you on the graph, huh?
Well, it's just I made enough room for exactly to get
22?
110,
Yeah.
and I didn't really think that through.
I couldn't remember that it was 120, so it's partially my bad. Okay, so we're going to get these ordered pairs, so we got 25, 25 right here. We're trying to maximize that one's probably not going to work. So as I do that, I'm thinking I'm multiplying my x value by 6 and my y value by 20. Right, so if I'm going to eliminate any points, I want to think about the fact I'm multiplying that y value by 20, because that's a lot.
I think it's 1575.
So right here, we got 50, 0. That's probably not going to be it either, right? because that one's 300, and we're already almost to 300 on this one, so I'm not going to plug that point in. So I'm kind of thinking along the way. Again, you could just plug in all 4 points and not go through this mental process, but that's no fun. 75, 15 is another place I could plug in. So 75 times 6 and 20 times 15, that's definitely in the running for the bigger point. And then all the way out on the end here, I got 120, comma 0. So that one's definitely in the running as well. And then if I'm thinking which one's going to be bigger between 75, 15 and 25, 25, 75, 15 is definitely going to be bigger, so I'm not going to do that one either. I'm just going to see which one's bigger between 120, 0 and 75, 15. We're almost there. So plugging those in, 75, 15, and 120. So you get 6 times 75 plus 20 times 15, and we get 6 times 120 plus 20 times 0. So I can do the bottom one in my head. 6 times 120 is 720. 20 times 0 is 0. Don't forget units. $720 for that. And then I already plugged the last period, the other equation in. Right, so I tested the 25, 25 as well here. I got 650. No, I have to do that. So 6 times, oh no, that's the one I wanted here. So 750. 6 times 75 and 20 times 15. That would equals 750. So, this is the one I want. Maximizes my profit at 750. The last thing you have to do is write a statement that answers the question. So God only knows what the hell the question was at this point, right? Like 20 minutes later, you don't know what the hell's going on anymore. I understand. So we'll go back and look at the question. So how much is the maximum profit? They also ask how many t-shirts and how many sweatshirts should you make to maximize that profit. So we're going to write a statement which answers those 2 questions. It's nothing crazy. Don't freak out about it. We know, right, X is t-shirts, so we need to produce 75 t-shirts and 15 sweatshirts to maximize your profit of $750. That's good times right there. Whew. So we'll go over this whole process again once you guys have this written down, because I know it's just long and painful, but totally doable is how I want you to think about it, right? Every single one of you can pull this off, but it's really easy to get lost along the way, so I can't tell you how important that organizational piece is. Notice, like, the first thing I do is identify those variables, then I'm going through and trying to figure out, like, the categories of equations I'm writing. So I did that by looking at these 3 bullet points. I whiffed on my last one there. That tells me that I need a minutes, number, and cost equation. And then here's our objective function where we're maximizing profit. Okay, then I went through and I solved. I'm still staying organized, right? I've got minutes, number, and cost. Because if you don't title these three equations, it's really easy to get lost along the way. So just keep it all nice and tightly organized. And then last, I'm going to the graph. I'm using the different colors so I can keep the equations separate, right? Because even that, if I graphed it in all black lines, the thing would be a nightmare, because you'd be super confused what the hell's going on. So then figuring out the shading as well, right? You got to get those inequalities, because if I had the blue line, if I thought it was less than, then it changes my whole problem, right? So it massively changes the whole problem. So just think about that. And then once I figure out the max profit, finally writing that statement to tell me how many of whatever it is I have to produce. Whew! So you only have 4 problems for homework. Okay? They're all not like this. You only have 1 like this, and then 3 others that are like the nuts and bolts behind this whole process. And we'll do another day of this tomorrow. We're going to do 2 bigger problems, which I will put on your quiz next week. I'll have to change the numbers. I'm not sure how I'm going to do it. I got to think about it. It's all different with the online stuff, but I'll figure it out. So yeah, linear programming, beautiful thing. All right.